or this is section 3.2, we're talking about domain and range. Okay, so a domain and range of a function defined by an equation. So you have your domain or your x values, and you put it through this function, say f of x equals x squared plus 5. And once you put that x value through that function, it's going to spit out a y value. So the x values are going to be your domain, and the y values are going to be your range. Okay, so let's talk about interval notation. In interval notation, the smallest number in the interval is written first. The largest number in the interval is written second, following a comma. Parentheses are used to signify that the endpoint value is not included or excluded. Brackets are used to say that the endpoint is included. Okay, so like this, if you have, say you have an inequality that x is greater than a, well, it starts at a and goes up to positive infinity, and anytime you've got positive or negative infinity, those are always going to have parentheses around them. Now, because this inequality doesn't have an equal sign, it's not a greater than or equal to, it's just a greater than, we're not going to include a, so that's why we have parentheses in front of a. Now, if you drop down to x is greater than or equal to a, well, now I have a bracket in front of a. Okay, now x less than a, so we're starting at negative infinity. That's the smallest number. Negative infinity goes up to a, and we're not including a because, again, we don't have the equal sign. We just have a less than. But if we looked at x less than or equal to a, well, then notice we have a bracket around a. Okay, and when you're graphing this on a number line, if you are working with parentheses, you can either have parentheses or you can have an open circle. Okay, so it could be like this. And this could also be open circle. But when it's brackets, it could be brackets or it could just be a closed circle, either one. Okay, now the interval notation, if x is between two numbers like is showing here, and x is not equal to either one of them, we just go between, so we have a, which is the smallest number, comma, b, and we have parentheses on either side. Now this is what it looks like on the graphing side. Now if you're going to include a but not b, well, then you're going to have a bracket around a but a parentheses around b. Now again, these could be open circles because they're parentheses. This would be a closed circle. This would be an open circle. Okay, and if you switch it around, well, now you're going to include b but not a. Well, now you have parentheses around a but a bracket around b. And you would have an open circle on a and a closed circle on b. And if you're going to include both a and b, you'll have brackets on both a and b, like you do here. And you will have closed circles or brackets, either one, on your graph. Now let's look at this right here. Find the domain of the function, and then here's your relation, because you have a bunch of ordered pairs put together. Now the domain of this function is just the first components of each of your ordered pairs. So you got -5, 0, 5, 10, and 15. Okay, so domain. Oops. Domain is -5, 0, 5, 10, and 15. Okay, and then your, if you were going to find the range, that would be the second values here. Okay, so range would be a 4, a 0, a -4, -8, and a -12. Okay, find the domain of a function. Okay, identify the input values, identify any restrictions on the input and excludes those from the domain, Write the domain in interval form if you can. Okay, so, or if possible, find the domain of this function. F of x is equal to 5 minus x plus x cubed. Now, when you're looking at polynomials, and this is just a polynomial, it's not divided by anything. We don't have a square root or anything like that. So the domain of this would be any real functions. So your domain would go from negative infinity to positive infinity. There's absolutely no restrictions on the domain, because what you're looking for if you have a fraction is what makes the denominator 0. Well, we don't have a fraction. When you have a square root, you have to set what's inside greater than or equal to 0. Well, we don't have a square root. So if we just have a polynomial, then your domain is always going to be from negative infinity to positive infinity. Okay, now this is the graph of the 5 minus x plus x cubed, and I'm using Desmos.com to show you this. Now notice your x values here. This function is going down and it's going up, right? And it's going to keep going down forever. It's going to keep going up forever. So that means your x values on the negative side will keep getting bigger and bigger and bigger. Your x values on the positive side will keep getting bigger and bigger and bigger, because this function keeps expanding upwards and downwards. Now find the domain when you have a fraction. So we're going to identify the input values. We're going to put any restrictions. So if there is a denominator in the function's formula, we're going to set that denominator equal to 0. We're going to set it equal to the thing that we don't want it to be and solve for x. That way we find the x values that we do not want. So if the function's formula contains an even root, set the reckoning greater than or equal to 0 and then solve. If it's an even root, what we need is inside of that root we need a positive number or 0. So that's why we set it equal to 0 or greater than 0, because something greater than 0, that's really just calling it positive. Okay? So if we're looking at this, find the domain of the function f of x equals 9 over x minus 6. Well, I have a fraction, so I'm going to set the denominator equal to 0 and solve. So add 6 to both sides. Okay, so x cannot be 6. It can be anything but 6. So what we write is we can start from negative infinity, go up to 6, but don't include 6. We can also have starting at 6 but not including 6 up to positive infinity. Okay, so this right here is basically saying you can put any x values into this function except for the value 6, because this is going to make the denominator 0, which will make the entire fraction undefined. Okay, let's take a look at this one. Find the domain of the function f of x equal to 1 plus 4x divided by 2x minus 1. Well, I don't really care about the top one because I don't have a square root or anything. All I care about is setting the denominator equal to 0 and solving for x. So 2x equals 1 divided by 2. So x equals 1/2, which means x can be anything except for 1/2. Okay, so we can start out in negative infinity, go up to 1/2, but don't include it, skip over it, start back at, we're not including the 1/2, but close to 1/2, and then going to infinity. So again, this is your domain, and it's saying you can put any x value into this function except for 1/2, because when you plug that into the function, you're going to get a 0 on the bottom, which makes the entire thing undefined. Okay, now let's look at this one. Again, I have a fraction, and on top there's no square root, so I'm just worried about the denominator here, so I'm going to set that equal to 0. And I'm going to factor this. Looks like I can factor 22 into, looks like 11 and 2. Okay, and I need a -2 and a +11. -2 times 11 is -22. 11 minus 2 is 9. Okay, so that checks out. Okay, so I have two things multiplied equal to 0. I can use the zero product property, which just means separate them and set them both equal to 0. Okay, so x equals 2 and x equals -11. So that means that x cannot be 2 and x cannot be -11. Okay, so x can't be 2 and x can't be -11. So we're going to start with the smaller number, the -11, so we can go out from -infinity up to -11, not including it. Combine it with -11, all the numbers from -11 up to 2, and then combine it with the numbers from 2 up to positive infinity. So this whole thing right here is the domain for this function. Okay, finding the domain of a function with an even root. So since there is an even root, we're going to exclude any real numbers that result in a negative number under the radical, basically. So we're going to set everything under the radical greater than or equal to 0 and solve for x. The solutions are the domain of the function. Okay, so if we look at this one right here, so I've got an even root. I know that because it's a square root, because there's no number there, because this and this are the same. So if you don't see a number right here, then it's assumed to be squared. So what I'm going to do is I'm going to take the expression underneath it and set it greater than or equal to 0. Because what we're saying is anything under this radical has to be 0 or it has to be a positive number. And we're going to solve for x. So I'm going to subtract 5. And then I'm going to divide by 2. So x greater than or equal to -5 over 2. Now remember, with working with inequalities, if you multiply or divide by a negative number, your inequality will flip. Okay, so we are including -5 over 2 because of the equal sign. It's greater than or equal to. And since it's greater than, we can go numbers bigger than -5 over 2. So what we can write is brackets -5 over 2, comma, positive infinity. So that would be the interval notation or the domain for this function right here. Okay, now let's look at this one. We have a square root on top, and then we also have a fraction. So first I'm going to look at x minus 4, set that equal to 0, add 4. So we know that x cannot be 4. And then we're going to set what is underneath the radical to greater than or equal to 0. And we're going to solve for x. So x is greater than or equal to -4. Okay, now we have to combine these two. We know that x cannot be 4, but we also know that x can be greater than or equal to -4. So we can start at -4 and go to numbers bigger than -4, except for the number 4. So we're going to start with the lowest number, the -4. So we'll start there. So -4. Notice we're not starting with -infinity because it says x is greater than or equal to -4. So we're starting there. So bracket. And we're going to go up to 4. So all the numbers between, and we're going to put parentheses because we're saying we're not including 4. We can have all the numbers between -4 and 4. And then we're going to union, start at 4, and then go to positive infinity. So this is saying, okay, we're starting at -4, going up, except excluding the number 4. And this would be your domain right here.